Okay, that's good. So this whole area, that's given by A or B. So that's probability of A or B. And that's A, probability of A plus probability of B. But if you are adding these two, then you're adding this middle bit twice, right? So that's why you're subtracting probability of A and B. Okay, so that's the formula for this bit here. And probability of A times probability of B. So if you multiply, if you have a tree diagram, if you multiply across, then you're going to get the middle area. So this is known as, so this times by this is probability of A and B. So this times by this is probability of A and not B. And that's just A only area, as you can see. Just that bit there. And this one here is probability of A naught and B. So that's B only. So that's going to give you that bit there. And so probability of A naught and not B. So that's not A and not B. And that's the area which is outside, okay? So that's what we did last time. So that's outside of those two boxes. We also talked about independent probability and dependent probability. So, and we concluded last lesson by saying that if this one times by this one equals to the middle there, so if probability of A times by probability of B equals to probability of A and B, then this would be independent, okay? So using, you know, the tetrahedral die, that we talked about this last time as well, and a cubical die, you can construct. We actually haven't done this one thoroughly, so I'm going to go through this again. Philip, do you follow everything so far? Okay, that's good. So remember this one, tetrahedral die and cubical die? Yeah, okay, that's very good. So 1, 2, and there's a behind, that's 3, and then that's 4, number 4 there. So there are 4 outcomes here, and the 1, 2, 3, 4, 5, 6. So event A, we defined event A as having 4 on the cubical die, and event B was having 6 on the cubical die. This is tetrahedral die, sorry. So if I draw what's called event space, then you can have 1, 2, 3, 4 for this one, and this one you can have 1, 2, 3, 4, 5, 6. I'm just going to zoom in a little bit there. So I can get a bigger picture. So in this case, I can have this as, so this event here is 1, 1. So this means it's a 1 on the tetrahedral die, and this means 1 on the cubical die. All right, so this is a cubical die, this is a tetrahedral die. So I can just fill this out. This takes a long time, but I'm just going to do it. 1, 3, 1, 4, 1, 5, 1, 6. And this is a 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. And then 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Okay. So this is known as the event space. So in probability, you will often have to do either an event space, you may have to do a Venn diagram, you may have to do a tree diagram. So it depends on what sort of question you get. Okay, so this is event space. and just put comma there. Now, Philip, in those in this event space, I want you to tell me, so how many outcomes are there? Total number of outcomes. 24, that's right. So that's very, very good. And I want you to also tell me, what is the total number of outcome for A or B? So I'm going to go for N of this. I didn't write P of this. N means number, okay? So I want you to tell me what N of A and B is, and also N of A or B. So I want you to think about that very carefully. You can take your time because Chris is not here. Not sure why Chris hasn't logged in yet. Maybe he's busy. Something else. Still working out? Okay. Can I actually enable your microphone if that's all right? Unless it's like too loud, you know? Instead of typing, we can chat. Is that all right? Oh, you're eating. Okay. So you can just type then. Okay, no problem. So I want you to tell me in this total number of 24 outcomes, which one of these, you can easily tell me, okay? I think you can answer this question. Which one of these is 4 on the cubical die and 6 on the tetrahedral die and 6 on the cubical die? Which one of these outcomes shows? So this one is saying this is a 1 on the tetrahedral die and 1 on the cubical die, right? So which one of these, can you see one outcome that has 4 and 6 on it? Can you see that? Yeah, 4, 6, that's one. That's right. So this one here is a 4, 6. So that's what this guy is, A and B. So I'll show you something. So I'm gonna color A with blue, and I'm gonna color B with the 6. I'll color with red. So in this case, I'm gonna say that, hold on, all of these is event A. Do you understand? Because event A means 4 on the tetrahedral die, right? So this is a 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, and it doesn't really matter what the outcome for B is, as long as you have 4 on the tetrahedral die, that's what event A is, right? Now, which row or column do I have to highlight as red? Can you see that? Can you tell me which row or column I have to highlight with red? Just as I highlighted this blue, this row here with blue. Yeah, exactly. So this is the last column, isn't it? So this last column here is B, event B. That's 1, 6, 2, 6, 3, 6, 4, 6. So that's what event B is, okay? I'm just going to tell you something. A and B is this one. So the outcome, A and B, has to satisfy both the blue and red. You understand? The A and B is simply the number of the outcome of that is simply 1, because there's this one here. Okay? 4, 6, that's the only one, right? What about A or B? What is the number of outcome for A or B? All you have to do is just count these guys here. How many here? How many? There's a 1, 2, 3, 4, 5, 6, 7, 8, 9. Exactly. That's right. But you can also calculate the A or B this way. The 9, oh actually, sorry. 1, 2, 3, 4, 5, 6. 6 there. And then plus 1, 2, 3, 4. Is that right? That's 4. And then you minus 1. I'll do that in yellow. 1. This guy here. Do you see that? So what we did was we add the blue with the red, but because we added this bit twice, we just subtract this one. And that is the same equation as that is just proving that A or B is the same as number of A plus number of B minus the number of A and B. So we can extend that to probability and we can get this equation right here. Where was it? Yeah, it was right here, wasn't it? This one. Okay? So that's what we did last time. We didn't look at it in this way. So if we write the Venn diagram, so let's have a look. So if we look at a Venn diagram, so this is the number Venn diagram, and this is probability Venn diagram. So if you look at the whole event space, I think just one outcome goes in the middle. That's A and B. A only is 1, 2, 3, 4, 5. So that's 5 here. So total, this is making up 6. Okay, and this one here is 4, so this must be 3. So that's 1, 2, 3. So that's B only. This one is A and B. Making sense? And this one is 15 on the outside. So if I write that as probability, it looks like this. This is a 15 out of 24, because this is out of 24. Hold on. I just need to... change my microphone setting. Hey, Philip, just wondering, if I touch my microphone wire like this, can you hear some like background noise? Can you hear that? That's annoying, is it? It's fine? All right. Okay, I'll try to minimize that noise as much as possible. So this is a 5 on 24. As you can see, this is 1 out of 24. Everything is just out of 24. That's a 3 out of 24. And if we build probability table from this one, so this is A, this is not A, this is B, and this is not B. B, not B. So we know that probability for A, that's getting a 4 on, so what's the probability of this one here? So this is A. So if you add these two, then you get the probability of A, which is 6 out of 24, right? But that is equal to 1 out of 4. And indeed, if you have a cubical die, if you have a cubical die, what's the probability of getting a 4? That's a 1 outcome out of 4, isn't it? So that's why it's a 1 out of 4, and not getting a 4 on tetrahedral die is 3 out of 4. And getting B, which is getting 6 on a cubical die, and that's a 1 outcome out of a 6, isn't it? So that's equal to 1 out of 6. That's a 5 out of 6, 1 out of 6, and 5 out of 6. Okay? And of course, this diagram here shows that this one plus this one is 4 out of 24. So that's also equal to 1 out of 6. And if you multiply this by this, have a look. If you multiply this one by this one, it's 1 out of 24, isn't it? 1 out of 24. And that's the middle area. This one by this one is 5 out of 24. And we know that that's that one there. This by this is equal to that one there, which is a 3 out of 24. And this one is 15 out of 24, right? And that's the outside, you know? All of this. And that's all consistent with this diagram. 1 out of 24, 5 out of 24, 3 out of 24, and 15 out of 24. Okay? Now, I can now ask you this question. Is event A and event B independent of each other or dependent on each other? I want you to think about that for now. Are they independent events or dependent events? Does the outcome on the tetrahedral die, does that somehow influence the outcome for the cubical die? The answer is no. How can this outcome here influence what happens on the cubical die, you see? So they are actually independent of each other. So if you go and have a look at this equation here, if the two events are independent, which means they don't influence each other, then probability of A times the probability of B will equal to probability of A and B. So let's have a look. Let's see if that works. I'm going to bring that to the bottom. So I want you to look at this diagram here. Oops, that's too big. So have a look at this Venn diagram. So we know that definitely probability of A is equal to, that was a 1 out of 4, wasn't it? So probability of A is 1 out of 4. And probability of B is equal to 1 out of 6, right? So if you multiply these two, what do you get? You get 1 out of 24, true? And now that is actually the same as this thing inside, which is the A and B. Okay, so when you multiply these two, and you see this is 1 out of 24. And that's this one times by this one. So if that is the case, then they are independent of each other. So you can sort of intuitively know that they are independent because you can see that these two are unrelated with each other. So somehow, like, you don't believe that there is some kind of magical force that comes out of this and then sort of influence the outcome for the other die, right? So they're independent of each other. So you can sort of, using common sense, figure out that they are independent of each other. And this is a mathematical way of proving that two events are independent of each other, okay? So we're going to look at now this one here. So this is what we did last time. I'm going to zoom out a little bit now. Yeah, okay. So this is what we did last week. And this was about Chris and Philip. Philip was waiting in a classroom, and this was about raining, not raining. And when it rains, and Chris's probability of being late is 60%, whereas if it doesn't rain, then probability of Chris being late to school is only 10%. So that's what we did, and we calculated this one times with this one is that, this one times with this one is that, this one times with this one is that one, this one times with this one is this one, and we filled out the probability table here as well. Okay, and we figured out that the probability of rain, of course that was given, so there's 30% chance of raining, and there was 70% chance of not raining. And so that's why probability of rain is 0.3. And as you can see, this one plus this one, this is 0.12, this is 0.18, which is this one, and that's 0.3 there. And we talked about the given probability of late given rain. So probability of late given you are here, which means given it's raining, the probability is of late is 0.6. And if it's not raining, probability of late is 0.1. And we figured out the probability of just being late, and which is of course just that circle there, which is 0.18 plus 0.07. Okay, so that's just being late, of course. Now, I want you to use this one, Philip. This one here and this one here, right? So probability of rain, I want you to times that by probability of late. So this is probability that it rains in Canberra, and this is probability that Chris will be late to school. Whether it rains or not rain doesn't matter, it's just probability of late in general. So I want you to multiply these two and see what you get. So that's equal to, 0.075, excellent. Now, I want you to compare this quantity with this quantity. So how much is this quantity here? Okay, so the answer is 0.18. So that's the middle bit there, R and L. So R or L is this whole thing. Maybe you couldn't see this one clearly, but that one there, that's the A, R and L, right? So that's actually the same thing as this. So that's equal to 0.18. Now, are these two the same? The answer is no, they're not the same, right? Therefore, the event R and L are independent or dependent? What do you think? They're not equal to each other. They are dependent. So in the previous case, here, when you multiplied this one by this one, A by B, it was equal to this one. See that? 1 on 4. You see the probability of getting 4 here is 1 on 4. Probability of getting 6 here is 1 on 6. And if you multiply these two, then you get 1 out of 24, which is equal to that middle area. And in that case, it's independent. But if not, it's dependent. So you can see that they are not equal to each other, so they're dependent. So for example, does Chris's chance of being late to school, does it depend on whether it rains or not? Have a look. What do you think? Does it depend on whether it rains, or does it not depend on, rain? Yeah, it does, right? Because, of course, here, probability of light here is 0.6, and here it's only 0.1. So you can see that 0.6, 0.4, 0.1, 0.9. So these changes depending on whether it rains or not rain. So that is the reason why this is a dependent probability. And we concluded last lesson with this question here. So if it is raining outside, let me just zoom that in a little bit. So if it is raining outside, so Philip is right in here in the classroom, and outside it's raining. What is the probability that Chris is going to be late? That's the late given R. So you are right here, so it's raining outside. What is the probability that Chris will be late to school? How much? 0. Can you tell me? Yep, 0.6. So that's pretty easy, right? So that's all in here. So if let's think about the opposite, okay? What is the probability that it's raining outside given that Chris was late to school? See, the scenario is, so it's opposite to this one. So one morning you arrive to school and you know that it's raining outside, and Chris hasn't arrived, and you can ask this question: what is the probability that Chris is late to school? And the answer is 60%. But you're in a classroom, imagine, and you don't know, and the window is closed and you can't see outside. It's completely blocked. Okay, it's completely blocked, and it's dark in this room, in the classroom. Okay, so you can't see outside. And one morning, Chris arrived late. That's right. So Chris arrived to school late. So you know the information. So previously, the information that you had was it was raining. But what is the probability, given that Chris was late to school, that it is raining outside? So that's an interesting question, right? So you have to write this down. So the formulas that we have learned so far is probability of A and A or B equals to probability of A plus probability of B minus probability of A and B. This was pretty much the only equation we learned, okay? Actually, another one. If it's independent probability, then probability of A times by probability of B equals to probability of A and B. Now, if it's a dependent probability, however, then it goes like this. Probability of A given B times by probability of B. So this is still A times B, okay? So A times B is equal to A and B. Understand? Another way is probability of A times by probability of B given A. So it could be A given B times by B, or A times by B given A. So this is equal to P of A and B. All right? So, in other words, I can rearrange this one and write it like this. Probability of A and A given B is equal to probability of A and B over probability of B. Likewise, probability of B given A. So this guy here is that one divided by this, right? So that's probability of A and B over probability of A. All right? So I'm going to apply that knowledge to here. So I can actually figure this one out easily from this diagram here, tree diagram. But I cannot actually see this one in the tree diagram, because in order to see this one, you need to actually have late and then not late and then R and then not R, and then you have to stand over here to figure out this one, right? But we don't have this. We don't have such tree diagram. So we're going to use this formula. So I'm going to apply that to these letters. That's going to be equal to, I'm going to give you a clue. It's going to be probability of L at the bottom. Okay? So using this formula, this is A given B, is A and B over B. So if you have a R given L, what's this going to be? Can you figure it out? Can you just finish this equation? I'll give you some time. I'll wait for you to finish. Yeah, that's very good. Where'd you get that N, the symbol? Did you use N? That's pretty clever. Okay, yeah. So that's R and L, right? That's R and L, and that's P. Okay, so we can actually work this one out. So using this tree diagram, we finished this Venn diagram, and we can see that the probability of L is equal to 0.25. That's this one plus this one. So that was done last time. So 0.25 is this one here. Now what's the probability of R and L? What's the probability of this one? Can you see that from this page here? Somewhere here. How much? Yep, that's right, 0.18. 0.18. So the answer is, this is a 18 over 25. So if I just make this into times by 4 and times by 4, then you get 100, and this is equal to 64, isn't it? 1 times by 4, 8 times, 32, 72, sorry. So this is equal to 0.72%, I mean the 72%. So that's going to be the probability for, for this question right here. So there's a 72% chance that that it's raining outside, provided that that Chris has arrived late to school. Okay, so that's how you do it. So this formula, so all these formula, that they're all important. So you just have to memorize them. So make sure you do them like as soon as possible. I'm going to try some questions. Okay? Now, have you tried this question last time? Question 7. So this is asking what is, I'm just going to zoom out. Yep, we're here. So question 7, so what's the probability of A and B? So that's a 3 out of, that's equal to how much? 4, 5, 13, isn't it? 3 out of 13. I think it's none of these actually. So the answer is not found here. Maybe it's a typo. So question 7, it's like this. Question 8, what is a A or B? We can just add them up, so that's all of this, right? So that's equal to 5 out of 13. Okay, so can we see that here? Yeah, probably they forgot something in the diagram. Now, let's have a look at this. Have you tried this question, Philip? All right. Question 9. So you just have to use the first equation. So I'm going to quote that from over here. So let's try. You just have to use this one. Okay? So you see how they gave you this, and this and this, right? So this and this and this. So you just have to figure out this one. So all you got to do is if you just rearrange that. So all you got to do is just add these two and minus this one. That's it. Okay. So I'll show you. If you rearrange this, you get P of A and B is equal to P of A plus P of B minus P of A or B, isn't it? So if you just add these two and then minus this one. Okay, so that's 4 out of 10, 4 out of 5, which is an 8 out of 10, minus 7 out of 10, so that's equal to 1 out of 10. So when you draw the Venn diagram for this one, so you can see that the middle bit is 1 out of 7, 1 out of 10. And because the A here is 2 out of 10, so this whole thing must be 2 out of 10, so this must be 1 out of 10 here. So that 1 out of 10 plus 1 out of 10 is 2 out of 10. This one here is 6 out of 10, so this here must be 5 out of 10, so that this whole thing is 6 out of 10. And the outside, so you can see that this plus this is 7 out of 10, right? Which is agreeing with this one right here. So this is a 3 out of 10 outside as well, like this. Now, I want you to ask yourself this question, number 9. Are these two events independent? Are they independent? I'll give you some time for that. If it is independent, again, so this is the formula here, PA times PB will equal to PA and B. I'm going to copy that here, bring it down. So I want you to test this one. All right, give you some time for that as well. So here's the Venn diagram. Well, here are the results. So you can just use, got to just multiply this by this. And compare that with the middle part. And you just have to tell me if it's independent or dependent, all right? You think it's dependent? All right, so what did you get when you multiply these two? So when you multiply these two, you get 3 out of 25, right? 3 out of 25. And we figured out the middle area, which is 1 out of 10, right? Because using this formula, we figured out that the middle area is 1 out of 10. Certainly these two are not equal, right? So therefore they're dependent, okay? So we can also, since this is a dependent, we can actually have a look at this and figure out the given probability. So we can try that as well. So I'm going to place that right here. So what is going to be the probability of A given B? So since they are, I just need to tell you something. If it's independent, probability of A given B, there is no such thing as probability of A given B, right? Because they're independent, you know? So whether you have given B, it wouldn't matter. This would be just probability of A, okay? So there's absolutely no difference between this and this. But if it's a dependent probability, of course, this will be different from this one here. So everything that I'm talking about right now may seem abstract, but as you do more questions, it will become more and more obvious, I think. So if you have a probability of A given B, so since this is you said this is dependent, we're going to go and have a look at this quantity here. So this is equal to that one over that one, right? So probability of A given A and B over probability of B. So we know that probability of B is equal to 3 out of 5. And A and B, we worked that out, that's 1 out of 10. So that's equal to 1 out of 10 over 6 out of 10. So this is the same thing as 1 out of 6, because 10 and 10 can cancel out, okay? So that would be 1 out of 6, okay? And using this, we can draw like a Venn diagram and stuff like that as well, but we're going to move on. Okay, I don't want to confuse you too much. Now, I want you to try this one, number 10. I think you need to use one of those equations here. You got 0.48, okay? So all you have to do is, whatever this is, that's that one plus that one minus this one, right? So if I write 0.66 equals to 0.32, this one, plus x, which is this one, I'm going to just leave that as x, and then minus 0.14. So that's equal to 0.66 minus 0.32 plus 0.14, right? So that's what x is. Is that how you did it? Then you get 0.34, yep, 48, that's right. So that's how you do it. Well done. I'm going to copy and paste this one on a different page. You can try this as well. Yep, right over here. Okay, we're going to try 11 and 12 now. So the following information relates to question 11 and 12. Suppose that 53% of VCE students are female. So VCE is like Canberra, it is like year 12 in Victoria, in Melbourne. So 53% of students, year 12 students, are female, and 85% of the students wish to go to university. And then 45% of the VC students are female who wish to go to university. So we can write this one as the probability of female is 53%, so 0.53. Okay. And we can say probability of U, that's 85%, so that's 0.85. And something is 0.45, okay? So can you figure out what goes in here, please? It's either F and U or F or U. So you think it's a F and U, all right, that's good. So these are students who are female and people who want us to go to university, right? So this is a female and university. Okay, so this is a U, so this is not the or symbol. So this is for university. Don't get confused about that. By the way, so you got this one. So we translated this into this, right? So what is the probability that a randomly chosen student does not wish to go to university? Okay, what you have to do first, I think, is finish this Venn diagram. And this is F, and this is U. And in this case, you are trying to figure out, all of the area that is outside of the university. Outside of the university. Okay? That's the answer for that question 11. But I know that F and U is 0.45, so that's a 0.45 there. And I think it's your job to finish this one. So fill all this out. So I'm going to call this part A. I'm going to call this part B. I'm going to call this part C. I want you to fill all of that out using this information here. Okay. Did you figure out A here, this area here? That's very good, 0.08. Excellent. And this one here is 0.4. Very good. C, you can see that the whole probability must be 1. Always. When you add this one, and this one, it must be 1. Okay? So it must be 1 minus 0.08, this one here. So this one doesn't overlap with anything. 0.45 minus 0.4, right? So this whole thing is 0.8, 0.93. So I think it must be 0.07 here. Okay, let me just double check. 0.85, 0.93. So yep, that's right, 0.07. Well done. So now you can answer this question. A probability randomly chosen student does not wish to go to university. So that's what this one is asking, is actually probability of outside of university. That's a U naught. That's all of the area outside of that. So what do you think? So that's what you have to do. And the second question here is probability that a randomly chosen student is male. So that means it's not female. So that's a probability of not female, and does not want to go to university, which means and not university. Okay. So you can try both, this one here and this one here. Still working on it? Okay. So you got 0.4 for question 12. Okay, let's have a look. So the outside of university, so probability randomly chosen student does not wish to go to university. So that's outside of university. That's this one plus this one. Make sense? So that's 0.15. So that's the answer. And probability the randomly chosen student is male and does not wish to go to university. That's just outside of the female, and also outside of the university. Remember how when we did the tree diagram, you know how this was like A and this was B and A dash, and this is a B and this is a B dash, right? So this one and this one is A naught and B naught, and that was the area that was outside, wasn't it? Remember? That's what we're trying to figure out. This is an F naught and U naught. Okay? So that's outside of the, or so that's outside of this one here. So can you tell me how much that is? 0.07 exactly. So that's the answer here. Okay? So that's how you do it. We're going to try 13, 14, 15, 16 as well. I'm going to try 16 first. Okay? So if A and B are independent, then which is true? So it's got a lot of things there, but maybe it may be helpful if I copy and paste that formula there. So I'm going to copy and paste this one and paste that over here so you can try this one. Just try this and pick your best answer. Okay. So pick your answer. Okay, let's have a look. So when, have a look at A first. So this is a probability of A given B. So you might think, what's the probability A given B? But that's essentially just probability of A. So there is no chance that probability of A can become probability of B. So this is nonsense, okay? Here, this is saying probability of A given B, which is probability of A, in essence, is equal to probability of A, and that is actually the correct answer. The reason is, have a look. If it rains, so this is probability of rain, and this is probability of no rain. And let's suppose that Chris's chance of being late to school is 0.6 and not late to school is 0.4. And probability here as well is also 0.6, and then this is 0.4. This is late and not late, okay? And if you have a look, you can see the probability of late is simply 0.6, isn't it? And it does not depend on whether it rains or not. So you can see that this bit here, have a look. This bit here is the probability that Chris is late, given that it's raining. That's equal to 0.6. Probability that Chris is late, given that it's not raining, that's equal to 0.6 as well, okay? 0.6. So you can see that whatever these are, and because being late to school does not depend on whether it's raining or not, these two is the same thing as just probability of late. There is absolutely no difference. So given raining, it doesn't matter. It doesn't help at all. Okay, so it doesn't contribute at all. So that's why this is the answer. When they are independent, probability of A given B is simply probability of A. Okay, and yeah, these are all wrong choices. So it takes a bit of time to explain all of them, but yeah, I think at the moment we don't have to go through this at the moment. So we're going to move on. Oh, we have a few more questions up there. Yeah, I want you to try 15 now. All right, so this is a probability of A is this, probability of B is this, and A and B is 3 on 10. What is the probability of A given B? So you can just use one of these formulas, this one here. Okay, it's a very simple one. So you're doing probability of A given B, and probability of, you can also try B given A. So A given B is A and B over B, right? So this one here is 3 on 10. That's A and B over B. So that's equal to 1 on 3. This one here is still A and B. This is B and A, but that's the same as A and B. So that's 3 on 10 still. And over A. That's a 3 on 8. So that's how you do it, okay? So you can simplify this as this is a 3 on 10 over 1 on 3. So you can use this technique. This times by this is 9. This times by this is 10. So that goes to the bottom. So that's 9 on 10. So that's the answer. For this one here, 3 times by 8 is 24. And then 10 times by 3 is 30. Right? So 24 over 30. So that's the answer for that one there. Okay. So, Philip, I'll let you try these two questions, 13, 14. And now you can try more questions. Or maybe you should try 17 up to 21. Okay, so it's so I'll give this page as homework to you. Yeah, so finish this one by tonight and send me the answers, okay? Unless you have an urgent homework to do, school homework, that's due on Monday or something. All right, we'll call it a day. I'll see you next time.